It is. Okay, thanks. I think we're running a couple minutes late, but thank you for staying. So I'm Nirav Doshi. I'm the APJ Games specialist. Um, Good to see someone from EA. I am ex-EA myself. Or are you from EA? I hope you are. Okay, I am ex-EA Hyderabad as well. Um, so I'm going to talk about a broad range of stuff. You would have seen all of us wearing these Build Run Grow t-shirts, and you would have seen Build Run Grow branding. I'm going to talk in a little bit in detail in what we mean by Build Run Grow and how we can help. So this is a very broad discussion, but bear with me. It'll actually make sense when I start talking about some of it. That's fun. So we're going to talk about how to build next generation experiences with games, and as you know, large game studios have all been using AWS for some of their most popular games. We have a large repertoire of games running on AWS. These are some of our customers. Almost all these customers benefit from AWS, and some of the standard things that you would expect from AWS is compute, storage, databases. But we also help across a range of other stuff, and that is what you will actually gain from today. So we also starting from game design, system design, going over to cloud native game development, as well as even advanced stuff like regulated gaming, spatial simulations, Web3. All of this is something that we help with on a regular basis. So if you think of an online async game, you would all start with a studio. This is where the development work happens. This is where you would have your developers either on-site or remote. All of these would then be building stuff and assets which go into a build pipeline. The build pipeline is where you would have your build. Once it has been published, it goes on to the store. This is where your player finds the game. Once the player finds this game, they launch the game, they arrive at a landing, the landing authorizes the player. This is where they get access to the game services. Once the player has access to the game services, these are served out of a caching layer or a database layer. And if there is additional content that the player needs to download, you would typically put it onto a CDN. The player would download it from a CDN, and then this is absolute bare minimum that a game would typically use. Now, if you are using a multiplayer, if you have your game is a multiplayer game, or if it supports a multiplayer game mode, you would have dedicated multiplayer game servers. This is where your player would connect to directly. There has been an addition in the recent times. We are seeing a lot of uptake of cloud gaming. And if your game supports, if you are hosting cloud gaming, your cloud gaming boxes would be running in the cloud, and then you would have the player connect to that over any kind of device, and then the cloud gaming device connects in uh, to the dedicated game service. Now, with all of this, a lot of data gets generated. Game services, dedicated multiplayer game servers, all of these generate a ton of data. So you need a game telemetry and analytics data pipeline, something which is able to take all the data, process it, make sense out of it. When you understand what's happening inside your game, you have the ability to fix that back. If you want to make design changes go back into the system and the game updates itself. Or it is also data that is available to the business to make sense of what's happening in the game. If you have third-party wallets, IDP, auth, anything else, if you have community or Twitch or live support of some sorts, this will all get connected to this system, and they will all be sharing data together. Once you have a lot of data, makes sense for you to use some form of AI ML to kind of either make predictions, to identify patterns and trends in your game. And with all this infrastructure, you also need live ops of some sorts, some observability to make sense of what is happening in the infrastructure, what's happening in your code. And then if anything, any alerts need to be generated, that kind of also comes through in this. Um, what we've done broadly, what I've shown here broadly, is build, run, and grow. And that's kind of the broad picture that we have around here. So there are these three broad strategies that we work across, and that kind of covers just about any use case and solutions that games require. And we work with all our customers across everything around here, starting from cloud game development all the way to kind of growing, engaging, playing your players. So I'll run through some of these, and I'll go through some of these in detail. I'll run through some of the slides quickly, but um, don't, like, I'll go back here. Don't this is meant to be a very broad discussion. There's going to be a lot of information that I'm going to throw at you. Not everything will make sense immediately, but keep the use case in mind. You don't need to keep the solution in mind at this time. The solution can be tailored and customized to what works for you. But what I'm interested in is for you to know that this exists. So that's really what I would expect from the audience today. There are a bunch of things that we see where customers come to us talking to us about a bunch of these problems, and then we try and cater to each one of these individually. So at a high level, these are some of the problems we see. Now, looking at build, run, grow, we start with build. As I talked about, this is the section which is where we focus on build. Now, when you're trying to build, and this includes with remote teams, you would ideally want to have some form of remote studio in the cloud. To have a remote studio in the cloud, we have a bunch of solutions that can help you with any of these. So there are ready-to-use solutions which kind of provide you with a virtual environment that your users and yourself can log in and start working on. There is also ready-to-use EC2 boxes with Visual Studio licenses. So sometimes this on-demand license is also a very good option for contractors, the ones who you don't want to buy a license for, but you just want to use a license for, let's say, 3 months until the time that they're going to they're going to perform work for you. With all those compute options, you need some form of storage as well, because your data is going to reside there. Today, what you shut down, tomorrow, what you start up, you still need access to the data that you worked on today. So there are solutions for that as well. And if any of this does not work, we have partners like Parsec, Teradata, who can also provide you with similar or same kind of solutions. So this kind of helps you with building a remote studio in the cloud at a broad level. From a DevOps perspective, whatever you're trying to do to code, build, test, and deploy, there are solutions we offer which provide you with a series of stuff that's available. There are a couple of these that are currently not being emphasized upon, not being built upon, but I just want to highlight that this exists. When you think about rendering in the cloud, we have ThinkBox Deadline. When you think about a game engine, AWS has promoted a game engine called Open3D Engine, and this is something I have a slide about which I'll introduce to you in a couple minutes from now. We have AWS Amplify, which is our ready-to-consume web and mobile application development platform. It simplifies and abstracts a number of underlying AWS SDK calls, making it a lot more easy. If you just want to authenticate, you may otherwise have to write maybe 20 APIs. This simplifies it by writing 2 APIs. You are able to perform the same thing there. So it's meant to be for web and mobile applications. We have Device Farm, which is another very important service for game developers. Every time a game developer builds a game, they want to test it on different mobile as well as physical devices. It can be a significant investment if you have to keep buying different hardware and different operating systems, different versions, to make sure your game supports the minimum and the best version available till date, latest version. Device Farm literally gives you access to a forest of devices, physical devices, that can run different versions of operating systems that work for you. And you can run your application test on Device Farm. So mobile applications, web applications, these are Device Farm is perfectly suited for that. Any of this doesn't work, you can still use EC2, which is our basic core service, to build the exact same on your own. You can use our Intel platforms, you can use our Mac, or you can use our ARM platforms to support you for ARM processors to support you for that. In addition to all of this, we also have partners like Perforce and Incredibuild. If you don't want to use Git, you prefer to have Perforce, we still have Perforce there as well. From a game designer, system architect's perspective, we have industry experts like myself who can help you drive. We can drive your agenda, your roadmap, and we can help you build with it. We also have a well-architected framework. If you're aware about AWS and if you've seen the well-architected framework, we have a games industry lens on top of the well-architected framework as well. That is the QR code for that in case you are interested. And right now we are actually writing the second version of that. I am part of the team who has written one of the pillars for the games industry lens as well. So this kind of covers the build aspect, talking broadly about the things that are available when you're trying to build. So how have these customers and what have they built and how have they built it? So example of Animal Logic, they've used Nimble Studios. Example of Gamercraft, they've actually built using Amplify and serverless. They've benefited from the solution. They've shared their solution here as well. We also have Quizbit. This is a quizzing platform. They have been using Amazon IVS and Amplify, which also has helped them quickly get onboarded. So how do they do this? An example of a customer like Borderlands 3, which is Gearbox Entertainment, is this is how their perforce deployment on the cloud looks like. They've shared this, and this is when, due to the pandemic, we had most of the people working remote. They were able to use this deployment to continue working without getting interrupted because of the pandemic. This is a sample system which I'll run through about. So we saw all those blue boxes in the previous slide. This is how you would put them together. A Take a look at the black box on the left and the black box on the right. The one on the left is the development environment. The one on the right is the production environment. Change in code gets committed to a repository which triggers an event to trigger a build. Once the build has been successful, it gets stored in a bucket, and the next stage continues to deploy it in a staging environment, testing environment. If that testing is successful, it gets promoted to production and gets deployed to the production. A very simplistic approach to CI/CD, just to demonstrate the different blue boxes that I just talked about in the previous slide there. This is a lot more elaborate build pipeline. This has been done with combination of EC2 Spot as well as EC2 Mac instances if you're trying to build build for the Mac or the Apple ecosystem overall. Here's another solution, which is a Unity build pipeline with Jenkins and EC2 Mac. Again, custom, something that works. Whatever any of these work for you or don't work for you, there's a way to customize it, and that's really what I'm highlighting. So what I showed you in one of the previous slides with the build, I was talking about all the ingredients you have available at hand. This is where we help you build the recipe or the architecture that works for your requirement well. So here's another architecture with IncrediBuild in the mix. So if your build times, if you have a very lengthy build time, you have a way to use cluster computing, grid computing to offload some of the build tasks to different CPUs in your network that are idle, and IncrediBuild helps with that. So building, when we talk about user experiences or your player experiences, an experience is built with a number of elements, and the game engine is one of the biggest element. As an example, I'm just going to quickly run through. There was a game we had called Crucible. It was taken off the market within 20 days, but the team was brought into another game called New World. If you've played New World, New World is a massively multiplayer online game. Some sample screenshots of that. Now, all of this was built with the engine I just talked about called O3D. The previous edition of O3D was called Amazon Lumberyard. After that, Lumberyard was rewritten completely, it was componentized, and it was published on to an open source platform. So this is now available on GitHub. It was renamed to Open 3D Engine, and this is the first kind of 3D engine which is AAA ready and is free. So yes, from AWS's perspective, you could be using just about any game engine, doesn't matter to us. But if you're looking for a new game engine, you may want to take a look at O3D. It's something which has these features and has been popularly supported by a number of big partners. You can see some very popular names out here. All of these brands are part of our partners in the Open 3D engine. So that's about Open 3D engine. I just wanted to touch, make that available. Switching over to Run, like we saw the build, we have Run, which composes of, which has game servers and networking and game security. So when you start with the build, these are the components we just saw in the Venn diagram, and the first thing you would start with is a global network, some form of high quality, secure edge infrastructure that will help you with your game. So you have services like Amazon CloudFront, which is a CDN. We have Global Accelerator, which also expedites or reduces the latency from your player between your player and your servers. We have Web Access Firewall, which is our security service. We have load balancing services. We have Security Hub, Advanced Shield, and AWS App Mesh. App Mesh, if you're using some form of containers, you can use App Mesh to kind of have a good communication between the different microservices. Shield Advanced is a service I want to highlight upon here, which is Shield Standard is something that every customer receives as part of the standard AWS offering. Shield Advanced takes the security, the protection to the next level. If you're going to launch a new game, or if you're looking at launching a new promotion or a new campaign inside your game, I would encourage you to look at Shield Advanced to protect your infrastructure from a DDoS attack. This is when we have a human shield available to help you to configure various things. They are able to identify a DDoS attack much early, and they are able to create some sort of filters to make sure this does not hit your infrastructure and help you with it. Moving further, if you're thinking about the rest of the infrastructure here, game services, you obviously need compute. So EC2, ECS, EKS, Fargate, these are our compute services. This is also available as bare metal, also available as virtual machines. Those are container-based services. If you're thinking about serverless, we have AWS Lambda and Amazon API Gateway. A combination of these will help you run your code without having to worry about underlying server infrastructure. For your player ID pool or a federated pool, you have Cognito. We can talk more about that if you're looking for a managed solution there. We have database solutions like Amazon RDS, which supports, I think, 15 different 15 different database engines. Amazon Aurora, which is available for both MySQL and PostgreSQL. DynamoDB is our flagship NoSQL database. Very powerful, very useful for games. There's also Elasticache, MemoryDB. We're going to have a talk done by Sandeep here and Kunal, which will follow right after this, which talks a little more about how they have used MemoryDB. AppSync is our GraphQL. If you use GraphQL, it is our solution for GraphQL. You can use AppSync with a backend of DynamoDB as an example and use standard GraphQL queries to work with your database without abstracting your database in a way. If nothing of this works, we also have partners like Axelbyte, Beamable. These have ready-to-use solutions that can help you quickly get your game running without having to build a lot of stuff yourself. Now, moving further, dedicated game servers. I touched on dedicated game servers in the architecture. This is where your player directly connects in. This is where your multiplayer game runs. We have infrastructure managed for you through Amazon GameLift. GameLift comes in various different flavors. I ran a talk last evening about that, but we are happy to give you a little more information if you want. We have an AWS booth downstairs. Please come down. I'm very happy to explain what each of these does. But GameLift is our ready-to-use solution for dedicated game servers if you're hosting a multiplayer dedicated game server. If you don't want to use any of these services, you can also use the compute services I talked about, and it will still work. We have a number of customers who don't necessarily need GameLift. Their game can run without the overhead of GameLift. It still works very well on EC2 Lambda. But for the specific use case of an online ASIC real-time game, GameLift is the solution that you want. It's a session-based game that you would be building, that you would host on GameLift, and it works seamlessly for that. We have hundreds and hundreds of games benefiting out of that. Thousands rather, why am I saying hundreds? If you are building a massively multiplayer online game with a really large map, generally if you've ever managed these multiplayer games, if your map exceeds the resources of one box, you end up sharding that into two, splitting that map into two, and then you have to manage between two boxes. So you would have a player in this part of the map. As soon as the player crosses the boundary, now the player has to be managed by this box, which means the metadata associated with it, player state, game state, all has to be transferred over. This can be a hassle at times, which has now been simplified by SimSpace Weaver. That's our ready-to-use service for something to do something of that sort. And we've got customers running something like 8 boxes fleets to run their massive maps. SimSpace Weaver has also found an unexpected adoption by a number of government agencies who are doing digital twinning, who are building digital twins of their cities. And they have been able to really use large maps um, through SimSpace Weaver efficiently to kind of have simulations of traffic and simulations of how much time an ambulance would take from point A to point B and things of that sort. So that's where we talk about run. As I talked about in the previous slides, these bullets, these dots or ingredients are available. How do we see customers put that together? What have customers run? I have a number of these examples, but I'm going to rush through some of these. I am happy to talk about each one, but these are all customers who've been building on AWS and GameLift and CloudFront and the services I just talked about here. Um, if you've played Warhammer 40,000, 40K Dark Tide, this runs on GameLift, Fleet IQ, Global Accelerator, and DynamoDB. New World is one of our flagship Amazon Games Studio. If you know Amazon Games, they have built this, and this has run at tremendous scale. On the launch day, it was with 700K concurrent players. It was hosting 700K concurrent players. In the first weekend, it had 900K concurrent players. So this is how big this game was. And a sample architecture, a very broad architecture is here. But below here, you can see the amount of, the kind of scale that they ran at. 150 million invocations per minute of Amazon Lambda. 23 million analytics events every minute. The scale of DynamoDB, gateway, Amazon API gateway, Elasticache, all is unprecedented. You could not have built this anywhere else on the world. So now, why build on AWS? I've been telling you a lot about building and running on AWS, but why? So some of these slides may be repetitive. You may have seen my other talk yesterday, or even Priya's talk earlier today. Some of these slides are repetitive, but bear with me. A good example is the scale at which Epic Games runs Fortnite. If you've played Fortnite, I can tell you you're running on AWS. You've seen the game run, the scale at which it runs. How do they benefit from this? Because the global infrastructure that Amazon offers you is uncomparable. There's nobody else who can build, who has any infrastructure at this scale. All the dark green boxes that you see is where we have regions, and all the other green circles and the yellow dots and blue dots are where we either are building or we are using an augmenting mechanism of some sorts to help customers with. Each of these regions that I talked about have multiple different availability zones. An availability zone is a combination of more than one data center. It's not one data center. So if I tell you that Paris has 3 availability zones, it's not 3, it can be 3, it can be 30 different data centers. But each of them are grouped together as an availability zone. Where you don't have an availability zone, we also have local zones, which is a much smaller footprint of what we run as a whole region, as a whole availability zone. So when in Australia, as an example, we have our regions in Sydney and in Melbourne, which is on the east side of the country. On the western side at Perth, we have a local zone. So you can still cater to the whole country overall with the 2 regions and the local zone. So that's how we worked with. Example of Ubisoft, they've used GameLift, they've benefited from GameLift. So I'll rush through this. If you're building a session-based async game, this is exactly the use case where GameLift has been built for. But can you run it on a container service? Yes, you can. Can you run it on Fargate, which is a fully managed container service? Potentially, yes, but I would say it depends. Depends on how your game is, how much resource it requires. Can you run it on serverless? Again, yes, but it depends. Can you run it on EC2? Absolutely, yes. That is where you can always run it on EC2, but with a lot of management that you will end up doing otherwise, which is otherwise offloaded over here. If you're building a turn-based, lightweight, real-time game, I would not recommend GameLift. GameLift generally works for dedicated multiplayer games, but the kind of multiplayer games that are turn-based are really slow, they are not real-time, and it is better suited to be run on container-based services, serverless, or even EC2. If you're building a persistent world, yes, you may want to use this, or you may want to use EKS, ECS, all of this with with state management. State management is very, very important because you don't want your server, your game world to be lost. In comparison with session-based async games, there is a possibility you have 50 players playing a game, something goes wrong, that session dies away, it is still okay. Your players won't mind so much. They can come again, join another game and play. There is some tolerance there. When you are building a persistent world, a world which is supposed to live for 6 months, you cannot afford the world to die and not be able to be rebuilt again, which is where your state management is the most important element. And you want to make sure that you have that capability before you choose one of this. Would I suggest Fargate? No. Would I suggest serverless? No. EC2, absolutely. EC2 works everywhere. Any other kind of game, if I'm not covering any of this, yes, with an asterisk, means it depends. Depends on your use case, depends on what we are trying to do, how you're trying to do that. So I hope this makes sense at a broad level of the amount of computing options you have available to build your games, whatever kind they are. When we talk about games, compute is available, but there's database, which is also another major aspect. I did a talk last evening with Kunal here, and we talked about the different options we have and the kind of use cases that you would have. We have purpose-built database services for games. Each one of these can serve one or more of the purpose that you have. Happy to have a chat in detail. I'm not going to run through all of these. So how have the customers run? So they use services that I just talked about, all of this. This is just a visual of that. We also have a custom game backend hosting on AWS. This is a serverless solution that one of my colleague has built. I am also building some sections on top of this, but what we have right now is also ready to deploy. This is available on GitHub. You can use this. This is running TypeScript. You can augment it. You can add more features to it. You can change the code. It's all up to you. I'm building the leaderboards part of it. This is currently identity that is available. We have friends also readily available in this, and leaderboards will also shortly be available in a couple months. Maybe give me 3 months before GDC. So we have this solution which helps you quickly get started as well. There is a persistent worlds game hosting solution. This also uses game lift, and it emphasizes on the need for you to persist the game in a storage and then use a mechanism to retrieve it and rebuild the world for your players. Here's a game messaging system, which is a serverless solution again, and it is able to support thousands of players. This is another game messaging, real-time messaging system that actually supports millions of players. So you have solutions catering to the kind of use case that you have. So that was about build. We did run. Moving on to grow. This is actually going to be the longest segment we have, but I'll try and rush through most of this. Engagement or success with a game is the most important. You want to make sure your game is successful, and there are various things that you need to know to kind of take your game to the next level. My bad, I added some of these. The animation is what is missing, so wait for those logos. I'll come to those logos, but I'll start on the top. When you're talking about all of this information that you want to kind of make sense out of, and then you add additional context, your marketing team, your production team, they will need this information to understand what is where. To start with, to collect the data, you need services like Kinesis, Kafka, MSK. You need storage like S3. You need Glue to make sense out of that schema. It has to be able to extract the schema of the data residing in S3. Athena to query the data that is lying in S3. Redshift to kind of have a copy and have a structured columnar kind of data warehouse kind of approach to querying and reporting that data. You have EMR to do map reduce, if that helps you reduce the amount of data you have to the kind of data that you want to query manually. OpenSearch, which is also a powerful platform for text-based logs and documentation of some sorts. You have QuickSight, which is also able to visualize everything that you do with all of this. And I'll touch all of this in a coming slide, how it is put together to make sense into a game data analytics pipeline. Game monitoring, we talked about all these different applications. You have so many different services in your game. components in your game, you need monitoring. CloudWatch is the best solution to kind of help you with that. It helps you across metrics, across setting up events, alarms, logs, synthetics, and there are a couple other recently added, Internet Monitor and one other service. They all can help you build a better observability solution for your application. If you're using some form of messaging with the player, you can use SNS and Pinpoint. Pinpoint helps you create a campaign. Actually, we've renamed Pinpoint. I need to update the slide. What is it called? It is messaging, Amazon Messaging Center or something. I'll have to double check, but we have these services which help you to communicate back with your player. We talked about a number of serverless solutions. When you build serverless, there is a challenge in troubleshooting, debugging that solution. It becomes a problem if you have to understand what's happening between two Lambda executions. X-Ray helps you build a wonderful debugging. It creates a workflow for you. It shows you what is happening between the different layers of your architecture where you're running serverless. Event Bridge performs transformation of data between two different platforms. You may want to benefit from that. There are services like Fraud Detector, which once trained is able to identify anomalies in data that you provided. Neptune, which is a graph database. So if you're trying to build social elements in your game, Neptune is the way I would recommend you to build that, because that gives you a managed approach to create links between your players. It can be done for fraud detection, anomaly detection, collusion detection, or it can also be done in a different manner where, similar to what happens on social networks like Facebook and LinkedIn, if a person performs activities like or share or something, those kind of create different nodes and you are able to see exactly what has happened in your system. A traditional structured database, or even mostly a no SQL database, is not suited for the kind of workload you would have for social networks, which is where GraphDB really shines. Talking about AI and ML, very popular, very common, all of us are using this. There are a bunch of ready-to-use services from AWS which help you with this. Mainly community hygiene is what we've seen customers use this. So Comprehend is our service which is able to read and understand textual data. So if a user has created a support ticket, you can use Comprehend to extract entities, sentiment of what is coming through. Is this customer angry, irate? Is the customer happy? Is the customer questioning something? That helps you automate the priority queues for your team to take a look at this request that has come in. You may also be able to use Comprehend in multiple other ways, as it is able to understand text given to it. Again, this is pre-LLMs. Comprehend has existed before LLMs came alive late in 2022. It has been running for a few years. Yes, you can use LLMs for the same use case, but Comprehend is a simple one API call to get a response back and start working with that. If you have text, that's Comprehend. If you have an image or a video, that's Recognition. It helps you perform the same thing. If I take a picture of this hall, it is able to identify a chair, it will be able to identify a table, probably it will be able to identify the paper and the pencil, and that is something you will be able to do to kind of use it in a different use case. One of the popular use cases we had during the pandemic was people have built solutions to use recognition to identify their employers walking into the office without a mask or with a mask. They were able to identify a mask and they were able to trigger somebody not wearing a mask, point them to the security and things of that sort. Similar thing was done for a construction company where they wanted everyone to wear a helmet. Every person who walked into the site had to be wearing a helmet. If not, they would be triggered, alerted by recognition. So there are these use cases we've seen a lot of customers build with. Personalize is a recommendation engine. So if you're running a platform with multiple games, Personalize can help you build that personalized experience for your players. Transcribe can convert audio to text. So if you have an audio clip, you can convert it to text and perform Comprehend on top of it. So you can have your customer support receive an audio message from your player with his question, their question, whatever they are asking. Use Transcribe to make sense, to convert it to text, put it to Comprehend. Comprehend will be able to extract what is happening there as an example. Poly is text to speech. Poly is being used by a number of game developers to generate placeholder audio before the real audio comes from your dubbing artist or whatever platform you're using for that. So you can use this, your developer can just start working with it without having to wait on actual art. Um, Amazon Lex is a chatbot similar to LLM chatbots you have, but more structured in nature. If none of these ready-to-use services work for you, you still have Amazon SageMaker and ready-to-use AMIs or containers, which will also help you quickly build and get ready with similar solutions of your choice with available algorithms, ready-to-use algorithms there. Further, if you're building for Web3 or Web3 of some sorts, we have a solution called Amazon Managed Blockchain, which provides you with a node on the public mainnet or a test net on Ethereal. So you have the option to, did I say Ethereal? Ethereum. You have the option to host that yourself. You also have option to run your own Hyperledger Fabric network using Amazon Managed Blockchain. We have solutions like Twitch, Prime Gaming, there's Amazon Publisher Services, App Store, Amazon Ads, Alexa. These are various different offerings which can be brought together to help you with your grow, retain markets, upskilling your team. For upskilling your team, we have training and certification and Repost, which is a community portal for support. So as you see, there is just a lot of all of this. Now let's put this together into making sense. So how have customers grown? Everybody, we've had hundreds and thousands of customers using AI and ML even before it became this trendy. Everybody starts with data. Here are examples of some big studios who've used data in different ways. They all start with data of some sorts. This is a data analytics pipeline that I was talking about that we will put together using these different blue and red boxes. And what you see over here is a pipeline that is ready to deploy, ready to work. Today, if you're using a third-party analytics portal, the problem you have there is you are limited by what that provides. If they provide you with 20 different features, you are limited to 20 features. You don't have access to raw data, and you are supposed to send your game data, your player data to them. Instead, here's a solution which you host on your own, you own the data, and you run everything on your own, ready to deploy, serverless, which means unless you are consuming it, you won't be paying for it. The stream over here, 2, 4, 5, 6, and 13, is a real-time processing. So this performs absolute real-time processing of your information, makes it available to your consumers. 2, 7, 8, 9, 10, and 11 is a batch processing pipeline. So we have both real-time and batch processing covered in this, depending on how your requirements are. Here's the CI/CD pipeline for your data, provides you with different dev, QA, prod, and a flow for all of that. How do you want to drive that? So with data in place, there are a number of use cases that you can now use AI and ML or machine learning for games. I can talk just about this slide for the next 90 minutes and it'll still not be enough because all of these features are valued by our customers. There is content creation and managing the content to start with, to running and improving player experience, to improving your operations. All of this can be done once you have the right amount of data. So if you've captured the data in the previous data pipeline as I was talking about, you have a way to build all of these in your game. Again, not comprehensive, just indicative. I'm trying to highlight that these are use cases that we work on. When we see a lot of user-generated content, like what Priya was talking about in the previous talk, we have services to help you moderate that. Ready-to-use solution, this is a ready-to-deploy solution which manages moderation of image and video, moderation of audio, moderation of text and documents that you have. This is the same solution. All it does is it kind of is able to segregate between 4, 5, and 6, depending on what your flow is or if you need all of this. Another content moderation reference architecture which takes in-game data like this, performs a moderation, applies a score to it, uses an analysis engine to kind of help identify or flag certain things. And this is the architecture for that. So the same things here. This is where you have the analysis being done, and then you have quick sight to visualize what's happening. Okay, here's a game tech cohort modeler where you receive information, sensors in your game. Sensors are basically any tracking that you use in your game. You capture information from there, publish it, basically push it into a Neptune database where this is where you would run your queries, you would extract insights, and then those insights are used for the data consumers. You can do various things like upselling, promotions, customized promotions, or even identify what's happening in a cohort in a scene where you want to see where my players in Bangalore are, what are they doing, my players in Delhi, what are they doing. So you have ways of using the graph database to isolate these geo or any kind of use case. An example of image processing, serverless in-game screenshot. So if you allow your players to take a screenshot inside a game, and that screenshot is allowed to be posted on a community portal which is public, before you will allow something of that sort, you want it to undergo some form of moderation. And if there is any kind of profanity identified, you would want to flag it and let a human take a look at it before it is made available and pushed out to the community site. So this is an example workflow for that. We are seeing a lot of this being used these days with elections in the state or in US, and there is a lot of political sensitivity, and we see a lot of customers valuing this. Profanity is now not limited to adult content, but profanity has kind of gone all around the board with politics and sensitive left and right wing. Here's a sentiment analysis. Again, this is a slightly old architecture, so you don't see X, you see Twitter over here. But yes, if you have a feed from Twitter which can be pushed through a pipeline which is able to identify, extract insights, identify sentiment, makes it available to the business user, the user is now able to navigate and fix the problem the players are reporting about. A fraud analysis and detection. This is a very, very high level diagram. It just uses two algorithms, RCF and XGBoost, to perform these kind of work. Live ops anomaly detection, an example, architecture again. Personalized game catalog, I talked about Amazon Personalized. You provide it with user events and interactions, item metadata and user metadata. With that, it is able to train itself and provides you with recommendations. If you have ever used one of the Amazon retail sites, the Amazon retail site provides you with a recommendation for every product that you are viewing. It is basically using a solution which is similar to Personalized, and Personalized was built out of that solution that Amazon retail had built. Player churn prediction and retention. This uses SageMaker and custom models to identify churn prediction. So you have lifetime value of your players. You have ways for you to identify how your game is doing, how your players are doing, and if there is a player who's ready to churn based on their lifetime value, you want to kind of take a decision of what you want that player to do. Do you want the player to let go of that player, or do you want to retain them? How much do you want to spend on it? All kind of attributes around that. So how have these customers grown? Example of Capcom, example is Rovio. Rovio uses almost everybody on everything is running on AWS. So there are combination of examples that I just talked about. Now we'll just move over to Gen AI quickly and run through some of the game features. So this is also a slide which Priya ran. I'm just going to touch on it again, but there are services which are available, which are ready solutions that you can use for these use cases. There are ones that you will have to build some additional stuff around ready to use services. And the deep ocean is where this is completely not something that is readily available, and you will have to build custom. Naturally, if you're trying to build something like a sound effect or a game asset, the theme of your game, the art theme as well as the theme of what you are going to use it for, where you are going to use it matters. So this is something that is kind of the deep ocean. Game bots, how should your game play is something which is very proprietary at times, and that also you can build with. When we talk about generative AI, a number of times customers bring up these challenges to us. privacy and security of my prompts, privacy of my output, what is my cost of inference if I have to build the whole thing, content moderation, proof of copyright and ethical conundrum around using generative AI. So all of this, we have our standard AWS pillars of security and privacy. The data that you have for your account, in your account, for your work, resides and is isolated in your account. It is not used by anyone else other than you, not by the service, not by AWS, not by the third-party models that we run on. Cost of inferencing, we've made a number of services available which help you improve, reduce your costs. So there's Trainium and Inferentia. These are the two specialized GPUs available. Trainium and Inferentia are specifically designed CPUs to train a large language model and to run inference models. So they have been especially tuned for that. Content moderation, I talked about in a couple slides, ready to use solution. And proof of copyright and ethical conundrum. Amazon models, we have Titan and the Titan range suite of models. They are all covered by what we call an indemnity clause. There's an indemnity clause against any kind of infringement of copyright, and you are protected by it for those set of models that we have. Okay, so questions that we get about customers are, which model should I use? How can I move quickly? What can I do with my data? So we start with solutions that are available. You have ready-to-use infrastructure for foundational model training and inferencing. Talked about Inferentia, talked about Trainium, GPU instances. There's SageMaker and a bunch of others that will also help you around with this. We have ready-to-use tools like Bedrock, which provides you with guardrails, agents, and customization capabilities to quickly get up and running if you don't want to build your own. So this is ready to use. And then there is the next layer of LLMs, like solutions like Amazon Q, which provide you with you will be able to quickly get up and running with Amazon Q for business, for developer, or for in QuickSight and in Connect. So if you're trying to augment your existing customers or your internal teams, you can use Amazon Q for business or for your developers to expedite their work. Touched upon this in Priya's slide as well, but Amazon Bedrock is kind of providing you with all these functions and features, is ready to use. All of these models are ones which are available. While I was talking about the indemnity clause, note that all the Amazon models out here have an indemnity clause that you can benefit from. A prompt flow which allows you to visualize and accelerate your AI development framework, very valuable. Knowledge bases, we talked about this in the previous slide also, but if you have a knowledge base, something which is custom to your business, to your game, to your specific use case, you use that to augment Bedrock's capabilities and then enhance the experience of your player by servicing through with it. So simple, basic way, Bedrock, you choose a model, you customize it with your data, connect your data sources, enable the task execution, and your system is ready to be consumed by your players. And as I was mentioning, your data is not used for service improvements, is not shared with the third-party model providers. You can be assured about that. It is going to only be used internally. Internally by you, not by us. Very important. There are some resources you can get started, ready to use, hands-on workshop, tutorial, and some documentation to get you kicked off there. Touched on Q. Q developer, Q business has different personas that it serves, different benefits that it offers. For developers, it provides with guidance on capabilities, AWS capabilities, debugging, testing, and optimizing your code, securing your code, accelerating development, transforming your applications. All of this your developers can benefit out of. Q for business provides you enterprise-wide knowledge base, quickly customize, build and customize dashboards that you need for your business, contact center, how supply chain impacts operations. All of this can kind of be brought together. Q developer has been very successful in reducing the average time for development, and on an average 57% faster. I am a C++ programmer. I have recently, for the last 2 years, I've been building a small custom game. I have used Amazon Q for Developer for that game. Building a double link list was just tab, tab, tab. Every recommendation, every next line that I am thinking about writing was provided by Q, and I was quickly able to do my development without having to wait. So it is contextual recommendation that it provides. It uses a right syntax. I don't need to worry about the syntax. Simplifies my work and makes it available. So a large number of languages, IDEs are supported. So that's where it is. Simple. It uses this information sent to Q developer, sends you the code suggestions. Data is not used or stored for service improvement. Here's a non-gaming customer, but this is a very big customer. NAB, National Australia Bank, is similar to SBI in India, and they have used Amazon Q Developer, where more than 50% of the code suggestions provided by Q were accepted by the developers, and they tracked it and they found value in it, and that's kind of a great example there. Examples of game studios are like Saltwater Games, Gamania, I'm not sure how to pronounce that, sorry about that, and Huge Games. They've all benefited by building on Amazon Bedrock. So conscious of time, right on time actually, you have everything that you need to build, run, and grow your games on AWS. And as our CTO, Dr. Werner Vogels says, that you can now build systems or games the way you always wanted to, but you could never build. So that's me. If you would like to connect with me on LinkedIn, that's there. This is a PDF copy of the presentation that I just showed. If you want to take a copy of that, it does not have all the slides, but it has a large majority of the important ones that I talked about. And in the PDF, I also have, towards the end, I have short summaries of each of the boxes, each of the services that I talked about. So if you're looking for a service, there is an immediate ready reckoner available. What is this service about in 2 lines? Okay. Cool. Any questions before I hand over to Kunal and Sandeep here? Yes, please. AWS does not generate 3D assets and models. At this time, Stable Diffusion is the model that is used mainly for text to image. So at this time, easy answer is a no. I'll encourage you to watch the reInvent for some new announcements. That's the only hint I can give.
Diffusion only can generate up to accuracy of like
2D.
2D only.
Yes.
And
So
for 3D also there
so
are AIs which are
yes,
able to generate up to like 65%.
correct. So there is a lot of work happening in that space. The only thing I can say is there is some work happening in that space. Um, if you are using PCG or if you are interested in PCG, that is also something that we are working with some of our partners. So procedural content generation is also something which is very, very valuable in 3D, 3D and 2D, depending on where you are kind of. So is being worked upon, nothing available right now is the best I can tell you at this time.
So recently EA Games,
Yes,
they have launched their game engine.
correct.
Generative AI based and ML.
Okay.
So what is your point of view on that, and how AWS is going to like compete with
So
EA?
I would think about this in one way. Game engines are client side. Um, Unreal is doing PCG work. Unity is doing PCG work. O3DE has some work happening in the PCG front. Um, Thank you for helping me. I learned something new today. I did not know about this engine with capabilities for PCG. So very good. Almost everybody is going to try and build some form of um, procedural content generation in a way that it enhances their developers experience. So definitely something that is a space to watch. At this time, the what is available is very limited. And from an AWS perspective, this is still client side. So we are not directly in the client side. We provide you with the capability. Once you have built the capability, to augment it with the backend side, that is everything that we help you with there. So for PCG, for an example, for PCG, if you need some dynamic instructions and prompts that need to go to the client, yes, you would run that on us. if that makes sense. But that prompt is still going to be used by the engine to do the work. I don't know how good, bad, ugly it will do that, but that's where we are.
Last question.
Yes?
Like CSC students are going to like this year are going to come in industry,
Okay.
but AI is going to compete with them.
Okay.
So what is like AWS expectation from CSC engineers? What they should know and like how they can build their resume and like in future how they can prepare themselves.
Very broad question. It's a very, very broad question. Happy for us to have a chat at our booth. But I would encourage, I would motivate it. 20 or probably 15 years ago, there was no role called cloud solutions architect. We are solutions architect in the cloud, a role that was created 15 years ago. AI is creating so many different roles which are in the niche. So as this technology grows, there's going to be a need for specialized people in that space. I would encourage them to look at these spaces and kind of focus on one of them or two of them that help you. That is broadly what I'd encourage. There will be new roles that get created. They should be prepared for it rather than be surprised about, oh, I didn't know about this. What do I do about it? So, broadly, very good space, very good time to be in. A lot of things are ready to use. A lot of things available to be researched as well. So, those who are interested in both sides of things can benefit from that, I would say. I hope that answers. Thank you. Thank you, everyone. Thank you so much.
So one more question.
Yes.
Okay. So I'm Karthik from Chitkara University.
Nice.
So we are taking classes for in Unreal and Unity. I'm taking classes for the students.
Okay.
So how much I can able to do it AWS in classes?
Again, Unity, you are still talking client side, but the moment you need some form of
No,
data
I
store.
want to do AWS classes. I want to take
Ah,
AWS.
yes. Okay.
So how
Let
can I
us.
interact with you?
Sure.
And,
I am at the booth. I will be at the booth downstairs. Please come down. I'm happy to have a chat with you there. Thank you so much, Karthik. Thank you, everyone. Have a wonderful day.